Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 6, Section 1, Perpendicular and Angle Bisectors of Triangles. So a perpendicular bisector is a line, like this one, CP, that goes through the center of a segment. So we're actually talking about a segment, and it's perpendicular to that segment, and it splits the segment into congruent segments. So it's a line that is perpendicular to a segment and bisects the segment. That's a perpendicular bisector. Let's take a look at this perpendicular bisector here, CP. It splits AB perfectly in half. What can we say about the two triangles that are formed? Well, let's take a look. You can see that this is congruent to this. This segment is shared between the two, so reflexively it's the same length. And then we have an angle here that's the same. So we have side, angle, side, side, angle, side. That means that these two triangles are congruent, and if they're congruent, then all of their parts are congruent. That means that this side and this side have to be congruent. No matter where we put C, this is always going to be true if C is on the perpendicular bisector. So that leads us to a theorem that says that in a plane, if a point lies on the perpendicular bisector, like C or D in this case, then it's going to be equidistant from the endpoints of the segment. The converse is also true. And the converse says that if a point is equidistant from both endpoints of a segment, then it lies on the perpendicular bisector. So it's on the perpendicular bisector of that segment. So both theorems are true. Let's take a look at this little problem here. You'll notice that we have 24 and 24, so H is equidistant from both endpoints, therefore it sits on the perpendicular bisector. And if it's on the perpendicular bisector, that means whatever this distance is here, FG, that has to be the same for EF. So EG is going to be twice this distance. FH is going to be, well, that's not hard because we can use the Pythagorean theorem since this is a right triangle. So we can just use the side 24 as the hypotenuse and 9.5 as one of the legs to compute the other leg. I'm going to leave the computation to you. Let's look at the second problem down here. On the second problem, we have that we have a perpendicular bisector. So BD is the perpendicular bisector of this segment. Therefore, D is going to be equidistant from A and from C. So that means that 3x plus 14 is equal to 5x. And when you work out that, you come up with x equals 7. And then if you plug in x into one of these, then you get the distance from C to D, which is the same as from A to D. So it's going to be about 35. And we'll continue this conversation in the next video.